Hey guys, so we're going to look at graphing some circles today. And so what you need to do is bring up your browser and or your app if you've downloaded this on your phone, but search for Desmos, which we've used in class. But again, you can use this on your phone, or you can just do it through any internet browser. And we are going to click on the Start Graphing icon, and it'll bring up the graphing screen from Desmos. So circles have a particular formula, and it looks like this. And so I wanted to show y'all the standard formula. That's like standard form. For a line, the standard form is, let's do 3x plus 2y equals 1. All right, and there we have a straight line. It has a, let me see, I'm going to zoom in so y'all can see it a little better. So it has a negative slope, and it crosses the y-axis. If you click on there, I'll tell you it crosses at 1/2 on the y-axis. And on the x-axis, it basically crosses at 1/3. And so there you have a line. If I want the line to change the line, let's just say I'm going to change this to 3. Well, then it shifted. You can see the line, like on the y-axis, it moved up from 1/2 to 1.5, 1 and 1/2. And on the x-axis, it moved from 1/3 over to 1. So changing the constant on that line caused the line to shift. So circles work the same way. So I'm going to get rid of that and show you the standard formula for circles, or the standard equation, sorry. So this is what the standard equation of a circle looks like. It's x squared plus y squared equals, and let's go with 1. And I'm going to lower this again so we can talk about our circle. A few things I want you to notice: that if you click on where the circle intersects with the x-axis on the positive side, you see that it's 1, 0. And on the negative x, it's -1. And this is what's going on here. The radius of the circle is 1. Now, here's the thing. Back here, this 1 in the standard equation, that is not the radius. That is r squared. If you take the square root of 1, you get 1. So that's why the radius happens to be 1 there. And you can also see that because the radius is 1, it goes up on the y-axis to 0, 1, and down on the y-axis to 0, -1. But let's say I change this to a 4. Do you see how over here, right there, the radius from 0 to 2 means the radius of the circle is 2, whereas in the equation, the constant there is 4. That's because the standard equation is x squared plus y squared equals r squared for radius squared. So if you need to know the radius, you always take this number, the constant, and take the square root of that. That's when we did square root practice yesterday. And hopefully so far this is making sense. So basically all the way around, so you're spinning from the center of the circle and you're spinning all the way around. The radius is constant from anywhere at 0, 0 out to the circumference. That is always going to be 2, no matter which direction you go. It doesn't have to be from 0 to 2 here. It can be anywhere along the circumference. That distance is going to be 2. Also, if you were given 2 points, like this, let's say this point out here, and from 0 Let me see if I can find a point. Anyway, it will always work out. If you use the distance formula, you will always get the actual radius. The distance formula can help you find the radius. Okay, so next I just want to take a look. I want to change the r squared a couple of times. Let's do 3. And you can see it falls at 1.732. If you take the square root of 3, you are going to get 1.732, like in your calculator or the graphing calculator. Actually, I can show y'all that real quick. Let me turn that. So if I do 3 and take the square root, 1.732. So there you go. Back to Desmos, there we go. And let's just put in another one. Let me put in 100. Now, it's not on my screen anymore, but it's out there. It's centered at 0, 0, and the radius is now a 10. If you need to see where this intersects anywhere along the circle, just click on a point and it'll show you where it's intersecting the X and the Y axis. Also, something I want y'all to take note of is if I ask you, is a circle a function? The answer is no. A circle is not a function because a function has to pass the straight line test. So if I put in a straight line like x equals, let's do -2. Uh-oh. Oh, I'm sure y'all getting frustrated with me trying to do this. But if I do x equals -2. There we go. And I lower this. You can see that my straight line over here crosses the circle at 2 points. There's 2 values for x. For x equals -2, there is a y value that's 9.798 and a y value that's -9.798. That means this is not a function. So keep that in mind. It'll help you with Algebra 2. That's a big part of Algebra 2. What is a function? What is not a function? This is not a function. A circle is not a function. Okay, let me get rid of that. Now, the next thing I want to show you is, and basically this is the last thing because I'm going to stop after this. I'm going to show you a circle can move around. It does not always have to be centered at 0, 0. So it can move left and right, and that's called a horizontal shift, and it can move up and down, that's called a vertical shift. Here's the thing. You will use horizontal and vertical shifts for parabolas, hyperbolas, ellipses, several things that you work with on into pre-cal and into calculus. So getting the idea of a vertical shift is going to help you a lot. And also understanding the vertical shift, it doesn't change. The basic rule I'm trying to get you to see today is not going to change when you move to the ellipses, the hyperbolas, the parabolas. Parabolas will be the next thing you do, and that'll be in Algebra 2. What I'd like y'all to see is basically I'm going to show you one shift, and then I'm going to close this out, and I want you to do the worksheet, and then there's a quiz following the worksheet. I think once you see this, you'll be like, oh my gosh, this is the easiest thing. So basically, when you go to graph and I give you an equation, if I give you parentheses, those parentheses are very important and they have to be worked into the picture. So let's say I want to take this circle and I want to keep the radius the same, but I want to move it over left 3 spaces. So what I'm going to do is x plus 3 and then y squared equals 10. Oh, wait, it's supposed to be 100. There we go. So can you see how, let me zoom in a little bit. Oh, it's not letting me. There we go. All right, my circumference went from 10 to 9, 8, 7, the outside edge. The new center of this red circle, the center of the green one is 0, 0. But the center of the red one, it's not marked, but it's -1, -2, -3. So -3 is where the new center of this circle will be. There is a connection between the -3 being the center of the circle, and it's -3, 0, and this formula. And it's that you can replace this x here with a -3. -3 plus 3 would give you 0, and that takes you back to the original standard equation. So anytime you do a shift, you're not looking at the +3, you're looking at what could I put in the place of that variable to make it go to 0. So a +3 actually will shift your standard graph over -3, left 3. So that's a horizontal shift. So I'm going to give you some more to practice on your own. Basically, when I start a new problem, I would clear everything out and just click X to clear it out. And then you can start a new set of graphs. So y'all go ahead and do that work today, and then there'll be a quiz following it. And that's it for today. I feel like it's pretty straightforward. I hope y'all enjoy it, and I will talk to you tomorrow. Thanks so much. Bye-bye.